So what can we do with this right here? So we see we got the sine double angle, we got a cosine double angle, we got a sine double angle with a phase shift. And we want to know what A is. So a little different than the problems we did in 7.2. And good morning, Emily.
Good
Let's
morning.
see. Options. Let's go check out our trig identities. So the angle shift is this sine angle sum formula here, which we applied a lot in section 2. And then we also have the angle, double angle sine, double angle cosine that it could apply here. And at first glance, it looks like double angle might be the way to go. So let's write that down and see what happens. So when you're playing around with these trig functions, you just got to try something and see what happens. So sine double angle is twice the sine of x times the cosine of x. Cosine double angle, we have three options there. And I'm going to go for the first one, which is the cosine squared of x minus the sine squared of x. So that is, again, this right here and that right there. And I haven't done the other side. This isn't a straight double angle, right? Because we don't have 2 times the whole thing. We could factor a 2 out. That kind of makes it more complicated, I think. So I'm going to leave that side alone for a minute, the right side. Let's see, what does anything happen to this? Subtracting the cosine, subtracting a negative sine, and maybe I'll reorder it. We'll just leave it in that order for now. 2 sine of x, cosine of x, minus cosine squared of x, plus sine squared of x. And again, you may be tempted to apply the Pythagorean identity, but that doesn't apply because this is a negative, right? It came from the cosine double angle. So this is just the opposite of the cosine double angle, not the Pythagorean identity. It's not a 1. And we could do some factoring, but not really much. If we think about, often when I want to think about factoring something like this, I rewrite it. So like, let's call cosine of x a capital X. So this would be capital X squared. And then let's call the sine a capital Y. And so we'd have a plus capital Y squared there. And then we might reorder that to have the Y squared first, plus 2yx or xy, I'm going to write xy, minus x squared. And if that factored, and usually only factoring is helpful if you have 0 on the other side, which we don't. So this feels like a total dead end. We'd have a y times a y and an x times an x. And if we want that to be negative, then one of these has to be positive and one has to be negative. And then that's the difference in squares. That'll end up being y squared minus x squared, and we have no middle term, so it doesn't match what's above. So that's a dead end. We can't incorporate that directly because it's not sine of 2 times something, right? That ain't there. So I guess this seems like a big unknown. So now we're going to focus on this right there. All right, so I think we need a new page too. So if this were a test, I would be getting definitely a blank piece of paper and rewriting that problem. So we've got sine of 2x. Let's see, was it minus cosine? Yep. Minus cosine of 2x equals square root of 2 times the sine of 2x plus a pi. And again, we're trying to solve for a there. All right, so the double angle on that didn't seem productive, so we're going to try the angle sum on this one right here. angle sum, so we get that square root of 2 hanging out. Let's just do that. And it says take the sine of the first angle, so sine of 2x times the cosine of the second angle, a pi, and then sine gets the signs right, plus cosine of 2x sine of a pi. What do we do with that? Let's see. Oh, we have that square root of 2 hanging on the outside. Now, a is a constant we're trying to find. So I'm going to rewrite that as square root of 2. I'm going to write the cosine of a pi first. Oh, there's not a 2 there because we applied the double angle. Oops. Typo. So we have sine of x here. And then we're distributing that square root of 2 through. So plus square root of 2. Let's write the sine because that's a constant. Because a is a constant. Cosine of x. Interesting. Oh no, I lied. That 2x does stay there. All right, reflect on the formula. Sine of the first angle is just the first angle. So apparently I was confusing that with the double angle. Oops. Okay, so back here, that is a 2x because that's a 2x, and that's a 2x because that was a 2x. So 2x, 2x, and now it kind of matches what I have up here. So let's compare these two. So I'm going to write this green one underneath. So that thing is supposed to be equal to the sine of 2x minus the cosine of 2x. So that would be 1 sine of x. Let's go plus -1 cosine of x. So this constant here, 2 cosine of a pi, has to be 1. And this one right here, 2 sine of a pi, has to be -1. So that'll allow us to find a. So again, we're comparing the right side to the left side, and this has to match that. This has to match that. All right, so off to the side here, let's try this one. Square root of 2 cosine of a pi has to be 1. Divide by the square root of 2. Cosine of a pi has to be 1 over the square root of 2. Equal, which is square root of 2 over 2. And thinking about the cosine, ooh, that was not a good circle. Let's try that again. Only marginally better. Cosine is an x value, so x equals square root of 2 over 2 is about over here. So that means we have this point here or that point there. And if we apply the arc cosine here, so then we would get a pi equals the arc cosine or inverse cosine, square root of 2 over 2. Arc cosine only knows about the top half of the circle, so it's going to say that's pi over 4. So now I have a pi equals pi over 4. Divide the pi's out, and we get a is 1/4. Now, technically, a could also be -1/4 because we could use that angle down there too. So, or -1/4 would be an option. Let's see what this one says. Does it say the same thing? Square root of 2 sine of a pi has to equal -1. So sine of a pi has to be -1 over the square root of 2, which is the same as negative square root of 2 over 2. And thinking about the unit circle there, Sine is a y value on the unit circle. So negative square root of 2 over 2 would be down here. And that would lead to this point or that point. And the arc sine only knows about angles over here between negative pi over 2 and pi over 2. So it's going to reply with negative pi over 4. So from here, I get, applying the arc sine, a pi is equal to the arc sine negative square root of 2 over 2, which is negative pi over 4. It's not a bad idea to check that on a calculator. So a pi equals that. Divide the pi's out, and we get a equals negative 1/4. All right, so could be 1/4, could be negative 1/4. We need to graph and check. We also need to look at the instructions to see if they give us any kind of boundaries on a. All right, so they say a has to be some number between 0 and 2. All right. So let's see, this is not between 0 and 2. This one is. Now here, an alternative, by the way, we didn't consider is this point here is also relevant to this situation. And the positive version of that angle would be what? 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4 looks like another option. So, or we could have a pi equals 5 pi over 4. Divide the pi's out, and we get a could be 5/4. And 5/4 is 1.25, which is definitely in this interval here. Okay, so maybe 1/4, question mark, maybe 5/4, question mark. Let's graph and see which one matches here. And Desmos has been doing very well for us lately. All right, so the left side said the sine of 2x minus the cosine of 2x. And we get that nice wave that looks like a regular trig function, like a sine function, and it turns out it is. And we found, which one is it? Let's see, we think it is the square root of 2. So now I'm thinking about the right side of this equation and the values for a we picked. Sine of 2x, right? Still have a 2x there, yeah. Oops. And then our first thought on a was 1/4. Ooh, get back over here. So plus 1/4 pi. And that did not match up. That's not the right shift. Okay. The other one was 5/4. That does not match up either. Oh, fascinating. Where did I make a mistake? What was the other option? -1? That one does match up. Okay, so let's see about that. Back to the notes. So we can't have a negative number. So -1/4 seemed good, so we just need to translate that. So negative pi over 4. Interesting. The period here, let's think about the period. That's always 2 pi divided by the multiple here too. So the period is pi. So we need to shift that negative pi over 4 by pi. Is that correct? I'm thinking we need to shift it by 2 pi. Let's see if we shift, because 2 pi relates to the a pi, not the a. I'm still thinking it should be 2 pi. Oh, let's try both, see what happens. So let's see. Pi over 4. So if I take 2 pi plus pi over 4, or plus negative pi over 4, that would be 8 pi over 4 minus pi over 4, which gives us 7 pi over 4. And then we're looking to match that with a pi. So a would be 7/4. And that is the right shift there. 7/4 is the positive version of shifting by that pi/4 there. Oh, yes, to use the pi, the period, we would have to factor that 2 out there, which we don't have factored out. Right? Because usually when we're talking about shifts, this is going to come up in the next section again. Our generic trig function is a times the sine of b parentheses x plus h, or usually we write x minus h actually, because it's opposite in here, plus k. So applying the period change, you would have to have that in factored form. All right, so my intuition was right there, I got lucky. All right, that was a hard one, right? We had a dead end. We thought we might apply the cosine or the sine double angle, that didn't work. We applied the angle sum formula, and that did work sort of once we poked around with the different versions of that pi/4 and negative pi/4. Oh, check this out. I now see. So here I got the angle negative pi/4, but in the problem, they said they wanted a positive version of A. So the positive version of this angle right here, let's highlight it, the pi/4 would mean to start here and come around this way. And that would be 2 pi minus pi/4. Yeah, so we wanted the positive version of that first one we found instead of the negative version of it. Now that makes sense. All right, so trig can sometimes be hard and it takes more than one try to get things right. Let's see what the computer thinks about my answer. So we think A is 7/4. Yay, got it right.